So what I'm going to go over here is a system for doing electron configuration. It's called the block system. For you to do this, you want to print out this electron configuration diagram that I have up for you. Or you could just take a normal periodic table if you like and do the same thing. But I am going to take notes on this, so that's why I'm doing it on this particular piece of paper. So for this, you're going to need 4 different colors. So I have pencils here. You could use whatever you want, but we're going to be doing some coloring here. So the first thing I want you to do is to label over here on the side what we call the energy levels. So these are energy level 1 through 7. So you're going to label them with a lowercase n. This is the principal quantum number. This is the energy level that the electron is around the nucleus. Again, energy level 1 is the closest, and you go the furthest is energy level 7. Now, do realize this is an older version, so this periodic table does not have all of the newer elements, but it does continue down, so you could draw that in. So first pick a color, any color you like, and we're going to label what we call the S block. The S block is going to be the first 2 columns of the periodic table here. So just take a color and color those in. And don't forget there is one over here on the right, so you want to color in this. This is hydrogen and this is helium, okay? So you could label that, and if you want, label the top column S1 and S2 as a subscript, and that will make a little bit more sense here in a second, so just keep that in mind. Then I have what we call the P block, so that's over here on the right, okay, so it's called the P block, okay, so pick a different color and color in the last 6 columns on the periodic table. And we're going to label each column P1, P2, P3, P4, P5, and P6. Then we have in the middle called the D block. Pick a different color. You're going to color in the 10 columns here. And each column labeled D1 through D10. Oops, D5, D6. Okay. And then we have the final block, which is called the F block. This is the intertransition metals. Most periodic tables have a way for you to understand where they go in the periodic table. So this is the F block. Again, your last color, you could color that in. And I'm going to label this F1 through F14. I'm not going to label each column because we don't usually go into this block directly, meaning any of the elements in here, because they get a little too complicated in terms of their electron configurations. So this block system is used to kind of figure out the order of electron configurations. And one other thing I do want to label are the noble gases. So we have neon underneath helium, we have argon, we have krypton, we have xenon, and we have radon. Okay, those will come in use a little bit later on. So while we are doing this, have a real periodic table so you could kind of reference it. I am going to do oxygen's electron configuration. So oxygen is right here. So I'm going to start with the top of the periodic table. Over here on the left, energy level 1 is where the electrons are going to fill first. So energy level 1 is a 1s2, then it is a 2s2, then it goes to P4. So I'm going to write that on another piece of paper. You could write this wherever you have space, on the notes or whatever. Oxygen, if it is neutral, has 8 electrons. So it starts with the top. Again, it goes 1s2, 2s2, 2p4. Okay, so these are superscripts, and this is going to be the number of electrons that you have in each one of these energy levels. And all of these numbers add up to how many electrons you have in the atom. So 2 plus 2 plus 4 gives us 8 electrons. So this is the electron configuration of oxygen. But let's try another one. Let's try phosphorus again. Find it on your real periodic table. Find it on your real, it has 15 electrons. So phosphorus has 15 electrons. 15 electrons. Okay, so starting at the top, okay, start over here. So 1s2, so I can have 2 electrons in the s orbital. Then I have 2s2. Then I have 2p6, 2p6, 6 is the maximum we can put in a p. And 3s2, then 3p3. So again, let me write it on this piece of paper. 1s2, 2s2, 2p6, 3s2, 3p3. Okay, again, if I add up the superscripts, 2 plus 2 plus 6 is 10, plus 2 plus 3 is 15 electrons. So this system just helps you get the order correctly. And you might be asking right now, well, everything seems to be going in order. Well, this is where things stop being in order once I get past this row. So please recognize the D block all have a 3 in front of them, but they're in the 4th row. So what I want you to do is write an arrow, okay, and write down row number -1. So the D orbital shows up after the 4s. So I'm going to do iron, okay. Iron is right here on the periodic table. It's in the D6 column. So I'm going to write its configuration here and show you where it comes into play. So I start at the top, 1s2, 2s2, 2p6, 3s2, 3p6. Then it goes 4s2 before I fill the 3d. Then it goes 3d6. So again, why I like this copy is they have the energy level and then what the orbital happens to be. So write out Fe. Okay, it has 26 electrons, 26 electrons. So again, starting at the top, 1s2, 2s2, 2p6, 3s2, 3p6. Again, this is where it gets interesting. 4th row, it goes 4s2, then it goes back to the D into 3d6, okay? Again, if you add up all of the superscripts here, you will end up with 26 electrons. Now, this is a lot of writing, so is there a shorter way of doing this? Well, yes, okay. Now, if I go back to the end of each one of these rows has a noble gas, and it ends as a P6. So we're going to use a noble gas configuration to kind of shorten it so that what we care about are the outermost electrons called the valence electrons. So we just want to know where those are located. So I'm going to go to the row above. Okay, wherever I see a P6, I could think of that noble gas. And I go, okay, well, if it ends in a 3p6, that's got to be argon. And I'm going to put it in brackets. That is how you do noble gas configurations. It needs to be in brackets, not parentheses. And then I go with any electrons after that. So I'm not done. So 4s2, 3d6. And again, these are what we call, I'm going to put a little box around them. Okay, these are what we call the valence electrons. Okay, those are the ones that get involved in chemistry. They react, they make bonds. So those are the ones that we care about. So we are going to continue on in the next video going over some more examples.